Now let's see the practical part of spatial information by using R. In this first part, we're going to use vectorial data, and the main package that we're going to be using for this is called SF, the SF package. So let's load the packages first, and I'm also going to leave the help for the package. Right here are the main functions. There's an option for searching also. So if you have any doubt, you can look for whatever you want here. And there's also additional material in Google if you want. And the links are in the theoretical class that we saw before. So let's begin by reading the data. My data would be in this format, GPKG. And this is a more modern format for spatial data, but it's very similar to the shapefile data. That's very common too. Readsf would be the function used to read all the most common types of spatial data. So if it's another format, you can have the whole name here with the extension, and it must work. So these are the limits that we have in this file. We have 118 observations. In this case, this would be the municipalities, and 3 variables. So this is the data that we have. This is the simple feature, which is the SF that the type that SF is using, and it's a multi-polygon. So these are the columns that I have available, the key for the municipality, the name, and then the geometry that's here as a multi-polygon. There's going to be a class about this. We have a projected type of data, UTM. So these large numbers are for the coordinates because they're in meters. So I can begin doing a plot, a map, with the key of the municipality and the name of the municipality. And since these are categorical variables, both of them have to use characters. So these are the categories, and you are going to choose random colors for this. So this is the spatial data that I have available. And R easily detects the objects. So R can recognize what type of object it is, and it's going to use the most adequate plot function for this. So I'm going to use with Glimpse to see the geometry. So these are multi-polygons, and these are the 3 columns that we have available. And we're going to add more columns afterwards. So as I said before, it's interesting to use this type of data because it allows us to use the different functions of the package, the deep layer package, as if it was a table. So I can arrange the rows here based on the area of the geometry. And I'm going to see everything organized here, but nothing changed. The area is one of the properties that can be calculated based on the geometry. But it's also possible to add another column for area and the variable of the limits that we're working with. You can see that I'm using this function, as dot numeric. Originally, this would be the result of the function. This is a function that has units. This will be meters, so there is going to be in square meters. And in order to do comparisons and other things, many times the units aren't necessary because not all the objects that are going to be compared have to be unit. If you don't have units, I understand that this is square meters. So this is not a problem because it's in square meters. Then I'll go to area. I'm going to see my limits. You're going to see the area column here with the values in meters. I can also use the filter function here to filter only the limits that have a smaller area. Five to 8, that way it would be the way to write it. So I have 80 municipalities, which are the smallest municipalities. And if I want to show the municipalities, I'm going to use a combination of plots. So the first plot is going to use this function stgeometry. In order to not use any of the columns like before, like the column for the key or the name of the municipality, then I'm going to use this function stgeometry to show only the geometry. And here I'm using a combination of the filter function, geometry, and plot to show what are the municipalities that have this area that comply with this criterion. So these are the municipalities that have an area that are lower than this limit, for example. So these are a few things that I wanted to show in order to understand what we can do with this. So the SF package includes all these functions, and you don't need to do too much to do simple things like this, to work with the data, to generate plots. All of this can be done in a very easy way. So now I'm going to do a plot by choosing the area column. So now we have 3 columns that can be chosen. If I use the plot like this one, I'm going to be able to see 3 maps. But if I'm only interested in one of the columns, I can select that column, and you're going to be able to see it like this one. This is a map where the color represents the area of the municipality. So this is the largest municipality that has the largest area than the others. So there are many other options to create simple maps like this one. Since this municipality has an area that's a lot larger than the others, it's not possible to see the difference between the smaller municipalities. So another option would be to use an argument that's called breaks, and this allows us to change the way on how the colors are distributed. Jenks would be a more natural way to see the colors, and this will allow me to see the variability between the different sizes of the municipalities. We can see the smaller municipalities are in dark blue, and we can see the color scale here. So this is one of the things that you can do. Something else I would like to show you is how you can read data that are spatial in nature and that have a common column that can be used to do a joint, as we saw with other data. So it's the same, but the only difference is that one of the data has the geometry column. So all the data is going to have this type of spatial data. So I'm going to read here in the file what are the census data. So I have 8 columns. The first one will be the key of the municipality, or clave, which is the common column that I have with my limits. And I'm going to try to join the data. So in the left, I have the limits, and I have this df, and my common column will be the key of the municipality. So what I try to do the join says that one of the files, the key of the municipality, uses characters, the one in the left, which are the limits, and the other, it read it as an integer. And this happens because this is a integer type of data, but they're saved in this geo package as a character. And due to that difference, it's throwing me an error and says it cannot join it because they're different. So what I'm going to do next is that I'm going to convert an eData frame. So I'm going to say here that the key of the municipality will be also as a character, and this will let me do the join as I want to do it. So it's important to know how to read the errors that appear in order to find a solution. If you saw my limits, all my columns are joined. So I have the 2 initial columns, geometry, and also the other 7 columns that were in the CSV data. This is very useful to join information that come like this. Let's say I have information that has the geometry, and additional information that only has the name in common, or a key, or the name. And by doing this, you can join the information. And afterwards, we'll see how we can do the same thing with the QGIS software. And finally, I'm going to show the data here. So I'm going to do the map of the yield using the same breaks in order to drill down the colors of the map and be able to see the differences. The data that has no values, that are NA, not available, are white or transparent, and all the others have a color. All this part over here, this region to the north and to the east, have a less yield, and this part over here have the highest yields. And this allows me to create a map that can be very useful. And finally, I am going to save this information. So this data set that has all the limits and also the yield information, I'm going to use this function that's called writesf to save the data, to write the data. The first argument is going to be the limits. Everything is joined here already. And the second argument is going to be where I wish to save the information. And based on the extension, the package is going to choose what type of data you have to save. So this will be the end of this initial part on vectorial data in the SF package.